Now we are discussing what are the causes for the instability of amplification. Why the transistor is not able to amplify in all circumstances. If we go to the basic, why the transistor is amplifying the signal? Because it is operating in the active region. The operating point is fixed here. But there is no guarantee that the operating point will remain until the end. The operating point may shift. We are asking the question, why the operating point is shifting? The first reason, either the VCE should change or IC should change, then only the operating point can shift. VCE is not changing. The IC is changing. If IC is changing, the collector current is changing, what is the effect? Definitely the operating point shifts either up or down. That will make the distorted output to appear. What are the different factors affecting in order to make the operating point shift, in order to make the IC to change? One is the reverse saturation current IC naught. Why the IC naught is increasing? Because of the temperature. When the temperature is increasing, obviously IC naught is increasing and IC is increasing. Thereby operating point shifts from the fixed location. When we change the transistor, the current amplification factor beta changes because of some damage or we replaced new transistor. At that time, the current amplification factor beta changes. Because of this change in beta, IC changes. Because of this change in IC, automatically the operating point shifts. So these are the causes for the instability of bias in the transistor amplifier. Now, we cannot control the temperature. And we do not expect the IC naught to decrement. And even we do not expect the beta to change. Even though they are trying to destabilize the operating point, we have to fix the operating point in all these circumstances. For that only, we will bias the transistor. We have different biasing techniques. One is fixed bias, which is also called as base bias, and the second one is collector to base bias. And the third one is potential divider bias. Which is also called as self-bias or which is also called as universal bias. We generally use the potential divider bias or universal bias or self-bias in order to make the operating point to be stable in any circumstances. Even though all these parameters are changing, when we connect the transistor in the potential divider bias, the operating point is stable. Because the operating point is stable, the transistor will amplify the signal even though the temperature is changing, even though the IC is changing, even though the beta is changing, irrespective of these instabilities. That we will discuss later.